All right, so we're in Algebra 1. We're on lesson 9-9. Today is our last lesson. You'll see that we have our last lesson. I can move back the quiz and the test to next week if we need more time for word problems. I'm pretty sure that I'm moving back the test at least to Friday. I might move the test all the way to Monday, which will really help us with grade checks. I'm like 90% going to move back the test, but for now, the test is on Friday. I've moved it back by one day. I'll probably move it back one more day, but just try really hard to understand these word problems. Today's date is the 5th of March, so 3/5. And yeah, we have more examples. So there's only 2 examples in our notes today. Most of today I want to spend on just playing around with word problems, letting you guys solve those problems. So, quiet raised hand. Who wants to read example 1? Go for it, Jenny.
Josie spends $15 at a fruit stand to buy 3 apples and 2 oranges. Fernando spends $30 at the same fruit stand to buy 6 apples and 4 oranges. Can we find the unit price for an apple and an orange?
Okay. Yeah, thank you. I'll take your card, your participation card. Thank you, thank you. All right, so we have the general problem. Looks like 2 of our own students of Levi High School are buying some fruit. So I need to identify my variables. Usually it's the thing that we're mentioning here. It's not money. It's not how the quantity. It's usually the things that we're talking about. So I need a quiet raised hand. What should my variables be? What are the 2 things that are consistently throughout this problem? Josie. Oranges and apples, exactly. Yeah, exactly. I'll take your card. And what variables do you want to make for those? What letters do you want to choose, Josie? A and O. Okay, so we're going to say A represents, I'm assuming A is going to be apples. It makes sense. A is going to be apples. And I know that I'm not being very specific when I talk about my variable. Technically, I mean A is the number of apples. But I think A means apples is good enough for us. And we're also going to say O is equal to oranges. We just have to be careful using variables like O because it looks like the number is 0. So I think for this problem, I'm going to say that 0, let's see, this is my practice. So if I do a 0 with a slash through it, that's going to be 0. And if I do O like that, that's going to be like the letter. Just so I can, for this problem, so I don't get confused between zeros and O's. All right, so now that's the hard part. I need to come up with 2 equations. By the way, there's this tangent that I want to go on really briefly for higher level math. If you have 2 variables that you're trying to solve for, apples and oranges, you need the same number of equations to solve for it. And this gets really fun when you hit Algebra 2, which you have like 3 variables. If you have 3 variables, how many equations do you need? 3. Yeah, it's a fun little rule. You talk about it a lot more in linear algebra and stuff too. Anyway, we need 2 equations because we have 2 variables. Who wants to try one of the equations? Only one person? I want to give you guys some time. I want us all to think about this problem. I see Andres' hand, but what are your equations? Give it a shot. Try to write it down. I'm going to actually stop the video now. I want to try to let you guys have time come up with at least 1 equation. Quiet raised hand. What is 1 equation? I need to see at least 5 hands. 1, 2, 3, 4, 5. Oh, tons of hands. Let's go with Gunnar.
6a plus 4o equals 30.
6a plus 4o, and this is not 40, it's 4o. I'm going to leave it like that. Is equal to, what did you say, 30? 30. What do you guys think? Is that a good one or a bad one? Thumbs up, thumbs down. Did he get that equation right? Everyone's giving you a thumbs up, Gunnar. Good job. I'll take your card. Yeah, so that is 1 equation. Gunnar just did the equation for Fernando because Fernando bought 6 apples. He bought 4 oranges, and he paid a total of $30. The numbers attached to them represent the price. So this equation represents price. $6 per apple, $4 per oranges, and $30. Everything here is in a unit of dollars. That's my check that I always do in the back of my head. Is everything in the same unit? Am I talking about dollars and quantity here? Oh, everything is in dollars. I'm good. All right. I need someone else to do another equation. Julian.
3 plus 2o
It's 15. What do you guys think? Thumbs up, thumbs down. Did you get that one? I agree, Julian. I'll take your card for that. Thank you, thank you. All right, so we came up with our equations. Now, we need to solve. What are we going to do? Are we going to do substitution? Are we going to do elimination? What are we thinking here? Elimination, I hear. Other people are nodding their heads. Elimination. All right, so let's do elimination. How are we going to do that? What are we going to multiply equations by? Raise your hand if you think you see a way. There's only one way that I see for elimination, actually, so there's not multiple ways that I see. I see 3 people have an idea. If you have your card, can you raise your card in your hand? That way I know I can give you preference. Jose.
The 3a is that equation. You can multiply it by -2.
Multiply this green equation by -2. All right, you guys agree? All right, I see lots of nodding heads. -2. This -2 is going to be multiplied to each of these 3 terms. All right, so Jose, go ahead and do that for us. -2 times 3a is a,
-6a
and then
plus
minus 4o,
equals
-30. Okay, thank you. All right, so I've rewritten the green equation into the black equation. Now I'm going to be looking at the yellow equation and the black equation. I'm going to be adding those two. I'm adding the yellow and I'm adding the black. So if you want to do a slight little scribble through that one to say, okay, we're not going to be using that one anymore. We've transformed it into the black equation. Don't use it accidentally. All right, so I'm going to add them straight through. 6a minus 6a is a 0. Yeah, so I'm just adding these up and I get 0. What about 40 minus 40? So 0 plus 0 is equal to 30 minus 30. Whoa. So it's 0. What do you mean by it's 0?
Josie cannot find a unique price for it.
So we cannot find a unique price for an apple and an orange. You're right. We cannot. So the answer is we cannot. Let's go ahead and write it. We cannot. But on Khan Academy, it's going to ask you why. And you have one of 2 options. Is it because there are infinitely many solutions or there are no solutions? Infinite solutions, 1 finger. No solutions, 2 finger. What do we think? Infinite, 1 finger. No solutions, 2 fingers. Interesting. We have a good spread. Some 1s, some 2s. So what I'm going to do is I'm going to go and flick back to my old notes. Let's see. Old notes. Let's go to Algebra 1, Unit 9. Where did we talk about it? Unit, was it 5? No, 6. It was 6 and 7. So let's look at 7. If I come back here and look at my notes for 9-7, notice what happens when we only do algebra. When we only do algebra, we get the following solutions. You get x equals y equals, okay, that had a solution. Obviously, we were not there. We're in either 0 solutions or infinity solutions. Which one do we get? We got 0 equals 0. That means we're talking about infinite solutions. So if I come back here to our notes that we're working on, we had 0 equals 0. So the answer again was infinite solutions. Write it down. This is infinite solutions. That is also going to be boxed because that's also part of the answer. We cannot because we have infinite solutions. It doesn't matter. We could say that an orange costs $100. Actually, that wouldn't make sense. We could say an orange costs $5, and we could say that an apple costs however other many dollars. Like, you can have an apple be any price, essentially. I could have an apple be $5 and oranges be $0. That's one price. We have infinite many solutions. Okay, let's go to example 2. I need another quiet raised hand. Who can read example 2 for us? Yeah, go for it, Jess.
What is that second one?
Oh yeah, so denarius.
The denarius was a unit of current in ancient Rome. Suppose it cost the Roman government 20
Denarii, yep.
denarii per day to support 5
Legionaries.
legionaries and 5 archers, and only cost 12 denarii per day to support 4 legionaries and 4 archers. Can we solve for a unique cost for each?
Yeah, that was hard, and you did a really good job. Thank you, Jess. I'm sorry that was so hard, but this is a type of problem that's on Khan Academy. I just changed the numbers. denarii was a unit of price, or a unit of currency. So it's like the dollar or the pound or whatever other currency that you're going to use. All right, so we have this currency. We're going to be talking about two different things. Notice that we're talking about archers and we're talking about legionaries. So legionaries, or legionnaire, I guess, would be the singular version of that. I'm pretty sure that's just a person that has like a spear, and then archers, long range, I shoot from afar. So we have people, spear people, and we have archers. I'm assuming that's the case. Those are going to be variables, yeah. So what variables are we going to use? I need someone to come up with letters. Andres. Legionaries? Yep. All right, I'm going to do a cursive L. That way I don't confuse it with a 1. That's going to be legionaries. Singular, just legionary. And then you said A for archers or R? A? Okay. A for archer. I don't know. I did archers. Should just say archer. All right. So we have our variable set up. Did I grab your card yet, Andres? Thank you. Thank you. All right. Next step, and the hardest step, is to come up with equations. And this is where I want every single person to come up with at least one equation. So I'm going to pause this now. Come up with at least one equation. All right. Quiet raise hand. With a card, if you still have it, what should my first equation be? Who still has their card? Yeah, Monse. 5L plus 5A is equal to 20. I agree. That is one equation. Thank you. I'll take your card. And who can come up with our second equation? Quiet raised hand with a card. You can still raise your hand without a card if you want. Cohen? There it is. Let's come over here to another color. 4L plus 4A is equal to, what do we say, 12. All right. We came up with our equations. Now, we need to solve. What are we going to do here? How are we going to solve? I hear some people saying substitution. Jose, what were you going to say? Yeah, use either way, right? Let's go with substitution because we did elimination last time. If we do substitution, we need to solve for a variable. I can solve for that variable, that variable, that variable, or that variable. We have 4 different variables to solve for. Which one do we want to solve for? Top left, top right, bottom left, bottom right. Here's some bottom right. Okay, let's solve for the A, the yellow A. So when I solve for the yellow A, that means I'm going to get rid of the 4L. I'm going to subtract 4L from both sides. So right now I'm trying to transform this yellow equation where it's A equals something. So I'm going to subtract 4L, minus 4L, minus 4L. Those 4L's cancel off, and I'm left with, on the right-hand side, 12 minus 4L. On the left-hand side, I have still a 4A. And then from here, I need to get A by itself. I'm going to divide every single term by what?
4.
By 4. Not 4A, just 4. Just the number in front of the A. Divide everything by 4. Chunk. Divide everything by 4. Divide everything by 4. So now I have A by itself. A by itself. 12 divided by 4. Shout it out. 3. Negative 4L divided by 4 is negative 1L. Yes, negative 1L or just negative L minus L. So I have solved for A. A is 3 minus L. Now I can plug in this A. Remember, this A came from our yellow equation. I don't want to re-plug it into the yellow equation. I want to plug in this A into the other equation, into this green equation, 5L plus 5A equals 20. So what I'm going to do now is I'm going to go over here to the right, and I'm going to rewrite this green equation, but in the place of A, I'm now going to have 3 minus L. Here we go. So 5L, just rewriting it down. 5L plus 5A plus 5. Ooh, I got to the A. A is no longer A. A is 3 minus L. So parentheses, 3 minus L. That is all going to be equal to 20. All right. What do I do next? Quiet raised hand, looking for cards, get some participation points in there. What do I do next? Sergio.
5 times 3 and 5 times negative.
Yeah, what is this process called? Do you remember? Starts with a D.
Distribution.
Distribution. There it is. Yep. So when I distribute that, can you do that for me, Sergio? I still have my 5L on the outside.
So it's plus 15 minus 5L
Equals 20. Yeah, thank you. All right. I've distributed the 5. I now need to combine like terms on the left-hand side. Combine like terms. Who can do that for me? I'm looking for cards still. I'm still going to call on people that don't have cards if I can't find anyone else. Yeah, go for it, Jose.
Did you put 5L and negative 5L together?
Yeah, 5L and this negative 5L. When I combine those two, I get 0. Okay, so now I have 0 plus 15 is equal to 20. Huh. That's as far as I can go. 15 equals 20. Okay, so can we find a unique cost for each solder? Did we get something like L equals 5? No, we didn't. So the answer is no, we cannot. Again. No. But why?
Because there's one solution.
We can't say it's because there's one solution. Let's go back again to our notes from 9-7. 9-7, which thing do we get? Do we get some variable equal to a number? No. Do we get some number equal to a different number? Some number equal to the same number?
The thing that's not that's equal to the
Yeah, exactly. We were right here. So 0 solutions. There are no solutions here. So let me come back over here. No, and then we'll say because no solutions. Oops, no solutions. So sometimes you'll say, yes, there are answers, and the answer is L equals this, A equals this. Sometimes you'll get no, and there's 2 different reasons why you can say no. Infinite solutions or no solutions. And now you've seen both of them. All right, all we're doing for the rest of the day after you write your summary is just working on word problems. All right, go ahead and write your summaries now. Make sure you remember what no solutions look like, infinite solutions look like, and then you can begin the homework on Khan Academy.